All right, welcome back. This is Martin Simplicity, and of course, if you are an engineering student or a science student, and you see a fulcrum and a rod, a ruler, whatever you want to call it, we're going to talk about something very important, which is moments. In engineering and science, moments simply talks about a turning effect, a force. Now, moment is a force, it has to do with force, but not just any type of force. A force that causes rotation. That's what I call moment, right? Some people can call it torque, but moment. So moment is just a force that can cause a rotation. Now, what is my reason and purpose for making this video? I just want to give a brief overview of what moment is all about, and most importantly, I want to show you the basic uh, things you must look out for if you're having challenge understanding moment, solving question moment. These are the basic things that might be your problem, which I just want to highlight. So if these basic things are not your problem, then you just need to study more and practice more questions and you'll be fine. Now let's start. Now, what is moment? Like I've said, moment talks about a force that causes a turning effect. All right, when you apply force and then you get a turning effect. Do you have practical, applications of this? When you have, as a very good example is the seesaw. All right, if I wanted to say if you're a child, but even if you're not a child, you used to be a child. When you go to play, except you didn't play when you were a child, and that was very boring. So when you go to the seesaw, one of your friends sits on the other end. I wish I can draw them. So your friend sits on the other end, and then you're on the other end, and then this one takes the other one up and all that. All those things are all the applications of moment. Now let me start with the first thing. Before we talk about moment, there must be a turning point, because you can't just turn a rod or a meter rule or whatever without any point. There must be a point where the rotation can occur, or rather, let me put it this way, there must be a point about which the rotation is going to occur. All right, so you can see that our turning point is this point right here. You can call it many names. We can call it a knife edge, a fulcrum, or whatever. So that is the turning point. So this seesaw is rotating about that point. That is where the seesaw is rotating about. So every time we're talking about moment, you must know that there is a point about which the rotation is going to take place. All right, so that's one. Now, another thing you must know, now let me just enter the mathematical aspect. Another thing you must know that the moment is given by force times perpendicular distance. All right, perpendicular distance, because now it's going to make sense to you in a few moments. It must be a perpendicular distance and force. So look at what I mean. So looking at this already, you can see that this moment depends on the force, meaning if the force is bigger, the moment is going to be bigger. If you have a bigger force, you have a bigger moment. That's when I say moment, just translate it like turning effects. The more force, the more you can turn. Right? Just imagine you have a spanner. That's a very good example. You want to use a spanner and lose a bolt. The more force you apply, the more the spanner can turn and lose the bolt or tighten the bolt. That's an example of moment. And also, the more distance, the greater the distance, the greater the moment. Using the spanner again, if you have a longer spanner, you see that it's easier to lose a bolt than if you have a shorter spanner. So that is just a very good example of the illustrating moments. Now let's say that we're taking our turning points from this place. Now let's say we apply a force, a downward force. All right, what do you think is going to happen? You notice that this rule, I don't know what I'm going to call it, this stick, this plank, whatever, is going to rotate in this direction. It's going to rotate like this. All right, if I apply force, let's say I'm applying a force of 5 Newton, it's going to turn it. What if I apply a force of, let's say, 20 Newton? It's still going to rotate in the same direction, but the rotation is going to be more, all right, because of the force is greater. All right, and so you can see that. So that's what we just established, that when the force increases, the moment increases. So let me just put something immediately. Now look at the way it is rotating this system. Let me just call it a system, right? See the way it's rotating this system. You see the direction of rotation. This is the same direction a clock moves. All right, say a clock from 12 1 2, the clock moves in that direction. So we call this a clockwise moment, because we have two types of moments. All right, so we have we have the clockwise moment, and we have the anti-clockwise moments. How do I spell that? Anti-clockwise moments. Of course, you can guess it already. So if I apply a force, let's say I apply a force from this point, it doesn't matter, 5 newton, 10 newton, whatever, it's going to turn it the other way around, right? Which is anti-clockwise, it's going counter the way the clock should go. So we have two types of moments, and whenever we're solving a question on moments, you either take the clockwise moment as positive and the anti-clockwise as negative, or you take the anti-clockwise as positive and the clockwise as negative. Now, which is the best? Most often than not, we take anti-clockwise as positive and clockwise as negative. So I've been able to establish that we have clockwise and anti-clockwise moments. That's a very good one for us to know, depending on the direction and depending on where the force is coming from. Good. Now, another thing we're going to talk about is how does the distance from the turning point, remember everything we're doing is from the turning point, how does the distance from the turning point affect the moment? That's one thing we want to talk about now. So let's see that. Now, I want you to be the judge. Imagine I apply a force. Now, remember, this is the turning point. Let me just call it point A. I apply a force of 5 Newton. Let's say from the point of application to the point A is, let's say, 2 meters. All right. And then I apply the same force of 5 Newton. So the force is not even changed, it's the same. Now, from point A, I'm applying it over a distance of, let's say, 10 meters. 10 meters. Now, without knowing how to calculate, which one do you think will have a greater turning effect? Of course, you know that it's going to be, the one that is applied at a greater distance, which is this force. Because of there is a greater distance, you're going to have, an advantage of length. So the bigger the distance from the turning point. Now this is from the turning point, so this turning point is very crucial. So you see that the more distance from the turning point, the greater the moment. Now take this into consideration. So if I ask you now, okay, let's just calculate the moment. All right, let's stop talking too much. Now let's calculate the moment. Let's call this force F1 and call this F2. What's the moment produced by F1? Let's call it M1 is going to be F1 D1. All right, so M1 is going to be, F1 is 5 Newton times, okay, let me just put the unit so I can actually show you the unit of moment. F1 is 5 Newton, all right, multiplied by D1 is 2 meters. So what's the moment going to be? M1 is going, 5 times 2 is 10, and the unit is going to be Newton meter. So moment, now I've already told you the unit for moment. Moment is in Newton meter. So this is the moment for M1. Notice that the force is still 5 Newton. Now let's calculate that of M2. M2 is going to be F2 multiplied by D2. M2 is going to be, what is F2? Surprisingly, it's still 5 Newton, and D2 is 10 meters. Now, what's the moment? The moment is 50 Newton meter. Now, you see that it is 5 times greater than the first moment, even though it is the same force. Now, this is a very wonderful machine, of course, because this is a machine. When we talk about levers, all right, far back to Archimedes and all of that, this is one of the most interesting innovations in science. You see that we have been able to have 5 times, output than we would have had applying the same force. So the only difference was that we had more distance. So moments is greatly affected by distance. The more the distance, the more the moment. Now, if you have understood these things that I have said, you know that moment must be taken from a point. Now, assuming our turning point, let me just make another illustration. Assuming our turning point is now this, and let's say the distance from F1 to this turning point is 10 meters, and the distance from F2 to this turning point is what am I going to call it now? Do the calculation. That's 12 plus, that should be approximately 20 if I'm correct. Yeah, 20 meters. You see that the M1 is going to be 5 times 10 now, which is now 50 Newton meter, and the F2 is going to be 5 times 20, which is 100 Newton meter. So you see that more distance is still going to produce more moment. And now you see that the moment has changed. Now notice that the F1 and F2, I did not even move their position. I just shifted the turning point, and the moment is giving me a different thing. So moment must be taken from a point. You need to identify the point you're taking your moment from, and then you identify the distance you're taking your moment from. This is the first requirement in getting comfortable with moments. This is just the very basic. All right, so maybe in the next video, let me not keep this video too long. In the next video, I'm going to discuss some other important. I'm going to discuss what happens when this falls, because I mentioned something about perpendicular distance, and up until this point, maybe if you're just learning this for the first time, you don't really know why I'm saying perpendicular distance. I'm going to show you what's going to happen when you incline the force at an angle. What will happen to the moment? What's going to change? Now you're going to see that, and it's going to make more sense to you. So please stay tuned and watch out for the next video.